Okay, so we're looking at this last example here where we're writing down an expression that gives the area of the region between our two curves f of x and g of x, and we're going to find the area. And we're going to use our graphing display calculator, but I'm also going to show you how to do it by hand because this is doable by hand. Okay, and remember, when we're trying to figure out the area between two curves, we're trying to figure out, okay, exactly where do the curves intersect each other, because those are our bounds, and then we're trying to figure out which curve is on the top and which curve is on the bottom, so that way we can plug into our formula. So using our calculator, we're going to type in those two functions into y1 and y2, and it doesn't matter which one is y1 and which one is y2 because it's just going to tell us which curve. We're mainly looking for which curve's on the top, which curve's on the bottom. And so when we graph this, we will see that the blue curve, which is the cubic that I put in, is there, and then the red curve is the quadratic, which you see there. Now, what it looks like is that from this point all the way up into this point, the quadratic's on the top and the cubic's on the bottom. But then from this point until this point, the cubic's on the top and the quadratic's on the bottom. So when that happens, you're actually going to have two separate integrals that you're going to find the area of and then add them together to get your total area. Because you can't say it's from this point to this point because the curve that's on the top is not the same throughout that entire interval. So whenever a curve changes from being on the top to being on the bottom in one interval, you have to split it up. Okay? So we're going to figure out the intersection of this point. So we're going to go to second trace. We're going to go down to option 5. And then we're going to do first curve, second curve, third curve. But I want to get closer to that intersection point. Oops, went too far. Okay. And I'm going to click enter, enter, and enter again. And I'm going to find out that that point is -2. I'm going to do the same thing for the other ones. Now I know the other ones, they look like, okay, well this looks like it could be 0, but I just want to be sure. Another one looks like it could be 2, but I just want to be sure. So I'm going to do it really quick. And yes, it is indeed at 0, and I'm just going to double check to make sure that this one's at 2, and enter, enter, enter. And yes, indeed, it's at 2. So when I look at how to write my equation, it's going to end up being the integral from -2 to 0, and then the integral from 0 to 2. Okay? Now again, if we look at from -2 to 0, the quadratic's on the top, which means you're going to do the quadratic minus the cubic. So the quadratic, which is x squared minus 2x, you're going to subtract the cubic from it, and this will be the first part of your integral that you'll need to evaluate. From 0 to 2, the cubic's on the top, the quadratic's on the bottom, so then we're going to have the cubic at the top, and then we're going to subtract the quadratic. Now it's important again that you're putting in parentheses because we want to make sure that when we subtract, we distribute over the negative in both places. So really and truly, this is the integral from -2 to 0 of x squared minus 2x minus 10x minus x squared plus 3x cubed dx, plus the integral from 0 to 2 of 10x plus x squared minus 3x cubed minus x squared plus 2x dx. Combining some like terms, and guys, you don't have to do it you don't have to actually show these steps. You could just, from this point, type it in. But because I wanted to look a little nicer, I'm going to see that my x squares cancel out, and I'm combining like terms to actually have the integral from -2 to 0 of -12x plus 3x cubed. That's a lot easier. Also, if I want to do this by hand to integrate, okay, by hand, that's a lot easier to integrate. And then from 0 to 2, I have my x squares cancel out. Combine like terms, I'm going to have 12x minus 3x cubed dx. Okay? Using the feature on my calculator, I'm going to do the areas between the two curves separately. Okay? So clear that out. I'm going to go to math, option 9, which takes me to this. And I just plug in -2 to 0. And then my first little bit that I want to do is -12x plus 3x cubed. Make sure I fill in the x. And I find that the area for the first part is 12. So I'm going to go back. So this very first part is 12. Now I'm going to add it to the area from 0 to 2, whatever that is. So the same thing, go to math, option 9, and you'll do 0 to 2 of, I believe it was a 12x minus a 3x cubed. Fill in the x. And I get 12 again. So then the area between the two curves is 12 plus 12, which is 24. Okay? Now I could have also done it by hand and gotten the exact same thing by taking the integral using our power rule, plugging in the values. Remember, plugging in the top bound first, subtracting from when you plug in the lower bound. But we still would have gotten 24. Also, if you go to Math 9 and your calculator just pops up this and not the fill-in integral part, like how my calculator does, well, don't forget you type in the function first. Even more of a reason to simplify it so you won't have all these numbers. Comma x, comma your lower bound, comma your upper bound. And you'll still have to do it separately for each of the two integrals and then add it together at the end. Now, just to let you know, give you guys a heads up, that your homework is not a real quiz. You know, it says take-home quiz, but it's more of the review for your real quiz that's going to be tomorrow. It covers the indefinite integral, the definite integral, area between two curves, and the area underneath curves. So please make sure that you do your review, your take-home quiz, your review, and so that way you're ready for your quiz that's tomorrow. All right? Make sure you bring any questions as well tomorrow.